Good morning. This lesson is for my Honors Integrated 1 class. This is for section 11.3. But before I get started today, I want to say that I hope that everybody is doing okay out there. So let's go ahead and jump into our goals. We have 4 goals today. Our first goal is going to be Introduction to the Gaussian Method. Our second goal is going to be to solve systems by adding. Our third goal is going to be to solve systems by subtracting. And our fourth goal is going to be to discuss special cases when it comes to linear systems and when we solve using the Gaussian method. So the Gaussian method is also called the solving by elimination, but I want to tell you a story about Gauss. Gauss was a mathematical protege. From a very young age, it was recognized that he had very, very good mathematical skills. I mean, phenomenal skills. At the age of 3, the story goes, he found a clerical error in his father's books for his business, which means he made a mistake with arithmetic, a 3-year-old. The story that I'm going to tell you now is about when Gauss was 8 or 9 or 10, and Gauss at the time lived Gauss lived during a time where only people that were rich got to go to school or were talented, and he was talented and he got to go to school. But Gauss, because he was so good at mathematics, he actually made his teacher upset, and the teacher would give Gauss these problems to keep Gauss busy because Gauss could absorb and just learn all the concepts so quickly that the teacher couldn't teach the other students in the class, so the teacher would give Gauss these busy work assignments to just keep him busy, and so he could focus his time on the rest of his class. So the story goes that the teacher wanted Gauss to add together the first 100 numbers. So again, think of an 8 or 9-year-old, right? So Gauss, at the age of 9, writes out the numbers like so. Here goes 1 plus 2 plus 3 plus ... plus 98 plus 99 plus 100, and I'm getting a little close to this, plus 100, and he said that that's equal to some number x. Okay? Again, this is a 9-year-old. My nephew's 9. There's such a radical difference between the skill set that Gauss has and my nephew who's 9. So a 9-year-old wrote out the numbers in order, to add up, and figured out that they would add up to some unknown number. But then he had an insight, and this is what made him so special, is he could see things that other people couldn't see. So this 9-year-old decides that he's going to write the numbers in the backwards order. 100 plus 99 plus 98 plus ... plus 3 plus 2 plus 1, and again, I'm adding the same numbers, I'm just adding them in a different order. These are going to, again, add up to the same value, x, which we don't know. And this is the main point of the story. This is why I wanted to talk about this, is this 9-year-old figured out that you actually could add equations together, 9. Okay, so what he did was he did this. He adds together the 2 equations. I don't know why I just traded pens. That pen was working just fine. He added together the 2 equations. 1 plus 100, that's 101. Plus 2 plus 99, that's 101. Plus 3 plus 98, that's 101. Plus ... plus 98 plus 3, that's 101. 99 plus 2, that's 101. 100 plus 1, that's 101. And then x plus x, that's 2x. So again, this little kid figures this out and created a pattern. Remember, we're really interested in patterns because once you create a pattern, you're able to use that to make predictions and control outcomes. So we have 100 101s. So I have 100 101s, and that's equal to 2x, And if I divide out the 2, you could calculate 100 times 101, divide that by 2, and that's what the first 100 numbers add up to. And I can only imagine how upset this teacher was that Gauss, this 9-year-old, figured out a shortcut to this problem that he was given that was supposed to keep him busy. I know, but it was absolutely wonderful. But the whole point of this, story is we can add equations together. So that was the reason why I wanted to tell this story about Gauss, is that we can add equations together. All right, so let's check off the first goal here, an introduction to the Gaussian method, which means that we can add equations together. And now I'm going to move on to my second goal, and that's going to be to solve systems by adding. All right, so I'm going to just make sure this camera's still working. I forgot my tripod at home, and it's still recording. Okay, excellent. All right, so I apologize that I wrote a little close. Let me divide that up so it keeps it separate, makes it a little bit nicer. So again, we can add equations together. And so here we are in the second goal, solving systems by adding. Gauss showed us as a 9-year-old that we can add equations together. And when I add these equations together, my x's are going to cancel. Okay, and I'm now left with 7y is equal to negative 7. I can now solve for y. And it's real easy to do. We divide out the 7, and we get that y is equal to negative 1. Okay, so now what we're going to do is we're going to plug in the y into either equation and solve for x. Sorry that I'm writing, this is super boring to watch, I'm sure. Okay. So I like the top equation. So again, I'm going to plug negative 1 in for y in either equation. I'm going to solve for x. I like what did I say? I like this one. Okay, so I get now 2x plus 3y, or not 3y, 3 times negative 1, and that's equal to negative 7. This now becomes 2x minus 3 equals negative 7. I'm going to add 3 to both sides. I get 2x equals negative 4. Divide out the 2, and I'm sorry I'm writing so low. And I get x equals negative 2. All right. So let me just make a couple observations before I continue. First of all, I have 2 equations in standard form. Okay, and remember, standard form equations are equations of lines. So these are equations of lines. Okay, we're going to do the IRL. And I found an x value, and I found a y value. And if I have an x value and a y value, I have an ordered pair. And what we actually found was we found the ordered pair where these 2 lines cross. That's what we're doing when we're solving a system by adding. We're finding out where the lines cross. Okay, I'm going to erase this right here just so we can put that in our notes. It's so important. We're finding where lines cross. All right. Ugh. This is not erasing very good. There we go. We are finding where the lines cross. Okay. And these lines cross at -2, -1. Okay. All right, so I'm going to go ahead and check off our second goal here, solving systems by adding. And I'm going to move on to our third goal here, solving systems by subtracting. And again, let me draw a line between these so I separate this and it doesn't leak over to the other problem. Okay, so again, I have two equations in standard form, so these are two equations and lines. And so I'm going to do what Gauss taught me that I could do, and I'm going to add together these equations. Okay? So when I add these equations together, I get 8x minus 7y equals -15. This is not good. Nobody canceled. Okay, so the way that we go about making somebody cancel is I recognize here that I have the same numbers. Now I want to make this clear. In both of these problems, the x's are going to cancel. Maybe the y's cancel. Okay, but it just so happens for these examples that the x's will cancel. But here nobody canceled. We are allowed, and the way that we're going to make somebody cancel is we are allowed to change the signs of all the numbers in the one equation. So I'm going to change the signs of all the numbers in one equation. So I'm going to erase this. Okay. And I think I'm going to change the signs in the top equation. So now I'm going to have -4x. That one didn't work very good, so you are retired. So again, this we're going to change all the signs of all the numbers in one equation. You're going to become negative, you're going to become positive, and you're going to become positive. And now what's going to happen, you're going to see, is again my x's cancel out. So now I get 9y equals to 9. Again, I'm going to solve for y, so I just divide out the 9, and I get y equals 1. I can plug in 1 into either equation. I like the bottom equation because the y is simpler. So now I get 4x plus 1, and that's equal to -3. I'm going to subtract the 1 to both sides. I get 4x equals -4. Divide out the 4, and here I get x equals -1. So my ordered pair, or the point that both of these lines cross at, is that they cross at -1, 1. That is the answer to this problem. This is where both lines have the same point, which means that it's a solution to both. Okay? So I'm going to check all solving systems by subtracting. And I'm going to have to erase a couple things to move on to the last goal, which is to discuss what happens during special cases. So give me 1 second while I do some erasing here, and I will be right back. I'm back. All right, so let's go ahead and move on to our fourth goal here, and it's special cases. So I'm going to go through this kind of quick because I know that this video is actually kind of long. So I'm going to use the Gaussian method, and that cancels, and so I'm left with nothing. And so since I'm left with nothing, I'm going to have to say I have 0, and 0 is equal to 14. This is a false statement. Okay, notice all the variables cancel. All right, I'm going to very quickly rewrite this in slope-intercept form. So basically to do that, I subtract the 3x to both sides, and I get y equals -3x plus 6. And I'm going to rewrite this one in slope-intercept form, and I'm going to get I'm gonna get negative y equals positive 3x plus 8, but then I have to divide out the negative 1, and I'm gonna get y equals negative 3x minus 8. And so I just really want to quickly show you what's going to happen here. All right, so, and I should have picked smaller numbers, but oh well. 1, 2, 3, 4, 5, 6. So my slope is negative 3 over 1, so I go down 3, 1, 2, 3 over 1, and I connect my dots. And then here I start at negative 8, 1, 2, 3, 4, 5, 6, 7, 8, and I go down 3, 1, 2, 3, and I go over 1, and hopefully this comes across as the lines being parallel, right? So all the variables canceled. I got a false statement. That means statement. I got a false statement. So what that means is there's no solution because they're not going to cross. Okay. So if all the variables cancel and we get a false statement, that means that we have no solution. Okay. I have this one right here, the second example. Let me go ahead and add these together. Use what Gauss taught us. This cancels, and this also cancels. So now I'm left with 0 equals 0. This is a true statement. All right, and so again, notice all the variables canceled. And again, we have, oh, not again, this time we have a true statement. Okay, so let me real quickly write this in slope-intercept form. I subtract the 2x to both sides, and I get y equals minus 2x plus 7. This one, I add the 2x to both sides, so I get negative y equals minus 2x minus 7. But then I have to divide everyone by the negative 1. And I also get y equals minus 2x plus 7. Notice that these are the same equation. And if I was to graph both of these, I literally am graphing the same line twice. And I hope that I'm on the screen here. So at 7, I go down 2 over 1. I do that twice. So these lines, it's the same line. And what this means is when all variables cancel and I get a true statement, that means that there's infinite number of solutions. Which is a consistent system that's dependent. This is an inconsistent system. Our first examples 2 and 3, those were consistent, independent systems. So hopefully this makes sense. I will also be doing a Zoom to answer any other questions on this. And I think that's it. Have a good day, everybody. Bye-bye.